All right, so getting into our sum and difference identities. Right now what we have is we got cosine of 60 degrees minus 45 degrees. So we have a difference of cosine. So we have cosine alpha minus beta. So if you go back to your identities for this, cosine alpha minus beta is just going to be cosine of alpha times cosine of beta. And then we're going to have plus sine alpha sine beta. Okay, just a second. I was just double checking that. I thought I had something wrong. We're good. So what we have is we have cosine of 60 degrees minus 45 degrees. So this is my alpha. This is my beta. So that's just going to be cosine of 60 degrees times cosine of 45 degrees minus sine of 60 degrees times sine of 45 degrees. Now, if you have your unit circle, hang on just a second, I'm trying to get my unit circle up here. Cosine of 60 degrees is going to be 1/2, and cosine of 45 degrees is going to be square root of 2 over 2. Oh, sorry, over 2, not square root 2. Then we're going to have plus sine of 60 degrees, according to your unit circle, is going to be square root of 3 over 2. And sine of 45 degrees is square root of 2 over 2. So that is going to be square root of 2 over 4 plus square root of 6 over 4, or simplifies into square root of 2 plus square root of 6 over 4. So if we have a sum or difference and we just want to find the exact value, or sum of difference of angles, and we want to find the exact value, just use those sum and difference formulas, and then use your unit circle to fill it in. So not only are you going to have a cosine of alpha minus beta or cosine of alpha plus beta, you also have to go backwards and realize if you have a cosine of alpha plus beta or alpha minus beta. So here we got cosine of 63 degrees, cosine of 18 degrees, sine of 63 degrees, and sine of 18 degrees. So what you notice is we got a cosine alpha, cosine beta, sine alpha, sine beta. Oops, that's not an alpha. Cosine alpha, cosine beta. So what we want to do is take this and write this expression as cosine of alpha minus beta for the particular values of A and B. So if you look, you see that this is cosine alpha, cosine beta, sine alpha, sine beta, means it's going to go backwards to a cosine of alpha minus beta. So it's just the reverse of the last one we had. And what we said is that our alpha is just at 63 degrees and that beta is just at 18 degrees. So what we have is cosine of 63 degrees minus 18 degrees. Put that here. So for us, for the most part, this is going to be something that's going to be on our unit circle. So we have 63 minus 18 is going to be 45. And if you go back to your unit circle, cosine of 45 degrees is just square root of 2 over 2. So if we rewrote the expression as just cosine alpha minus beta, we know that alpha is going to be 63. We know that beta is going to be 18. And we know that we're going to rate this as cosine of 45 degrees, which then is just going to be square root of 2, oops, over 2. Sometimes we don't get something that is telling us what the two angles are. So we use one or more of the sum or difference identities to find the exact value of the expression sine of 75 degrees. So that means if we want to use the sum or difference identity, we have to rewrite 75 as a sum or difference. So we want to use things that are on the unit circle. And what we see is 45 and 30 are on the unit circle. So we can use 45 plus 30. So if you go back to our identities, we have sine of alpha plus beta is just going to be sine alpha cosine beta plus cosine alpha sine beta. Or we have sine alpha minus beta, which is then going to be sine alpha cosine beta minus cosine alpha sine beta. So we have a sum here. So this is going to break up into sine of 45 degrees, cosine of 30 degrees, plus cosine of 45 degrees, sine 30 degrees. So sine of 45 degrees is just going to be square root of 2 over 2. Cosine of 30 degrees is just going to be, cosine, sorry, square root of 3 over 2. I was looking at sine for a second. Cosine of 45 degrees is going to be square root of 2 over 2. And then sine of 30 degrees is going to be 1/2. So here we get a square root of 6 over 4 plus a square root of 2 over 4. So we get a square root of 6 plus a square root of 2 over 4. So depending on the problem you have, sometimes you can use a difference instead. That might be easier. Just check this. So we could use 120 degrees minus 45 degrees because 120 minus 45 is going to give me 75. So you could have set it up like this instead. And now we have a difference. So this is just sine of 120 degrees, cosine of 45 degrees, minus cosine of 120 degrees, sine of 45 degrees. So we get is that sine of 120 degrees is going to be negative 1/2. And cosine of 45 degrees is going to be square root of 2 over 2. Sine of 120, oops, just a second, I wrote this one backwards. I think I put your cosine here. Let me go back and check. Yeah, sorry. Sine of 120 degrees is square root of 3 over 2. Cosine of 45 is square root of 2 over 2. Cosine of 120 degrees is the negative 1/2. And then 45 degrees is once again square root of 2 over 2. So we get square root of 6 over 2. Negative and negative makes a positive, so we get square root of 2 over 2. So square root of 6 plus square root of 2 over 4. So you get the same answer. So you can use a sum or a difference, either one, just as long as you set up get the correct angles, will still give you the same answer. So depending on what you get on your exam, you may want to use a sum or you may want to use a difference. And then remember, sometimes you have to work backwards. So we got cosine of 20 degrees, cosine of 10 degrees. Also remember this could be in radians as well. Cosine of 20 degrees, sine of 10 degrees. So you can look at this as alpha and beta. So sine alpha, cosine beta, cosine alpha, sine beta. Well, that is just going to be sine of alpha plus beta, which is going to be 20 degrees plus 10 degrees. So this is just can combine into just sine of 30 degrees. And sine of 30 degrees is just going to be your 1/2. So we can find the exact value of sine 20 cosine 10 plus cosine 20 sine 10 by just going backwards with the identity. Don't forget we have sum and difference formulas for tangent. And like I said, you could have radians. So we want to rewrite the expression, write the expression as a sine, cosine, or just tangent angle, and then find the exact value of the expression. So we got tangent of pi over 5, tangent of 2 pi over 15, minus 1 tangent pi over 5, tangent 2 pi over 15. So we got a plus here, we got a minus here. So we're looking at this identity, which is tangent alpha plus tangent beta, 1 minus tangent alpha, tangent beta. So this is what is just tangent of alpha plus beta. So if we have tangent of pi over 5 plus tangent of 2 pi over 15 divided by 1 minus tangent of pi over 5 times tangent of 2 pi over 15, then what we have here is just tangent pi over 5 plus 2 pi over 15. So if we change that, that can be 3 pi over 15 plus 2 pi over 15. So we have tangent of 5 pi over 15, which that's not on my unit circle, but if I simplify that, I have tangent of pi over 3, which is on my unit circle. All right, so remember that when you have tangent, what you have is you're going to have a sine over cosine. So it's just really just sine of 3 pi over 3 and cosine of pi over 3, which is just going to be pi over 3 at 60 degrees. So that is going to be square root of 3 over 2 divided by 1/2, which simplifies into square root of 3. Okay, so here, oops, let's ignore that little part right there. What we have here is, sorry, I just lost my color. Tangent of 11 pi over 6 minus 3 pi over 4. So we have a difference. So we have a tangent of alpha minus beta. So this is just going to be tangent of alpha minus tangent of beta over 1 plus tangent alpha tangent beta. So this is just tangent of 11 pi over 6 minus tangent of 3 pi over 4 over 1 plus tangent of 11 pi over 6 and tangent of 3 pi over 4. So if you use your unit circle, remember you're going to have to calculate tangent using sine and cosine. So your tangent, 11 pi over 6. So if you have your sine on top, that's going to be negative 1/2. Cosine on bottom is square root of 3 over 2. So this one is just negative 1 square root of 3, or negative square root of 3 over 3. And tangent of 3 pi over 4. So sine of 3 pi over 4 is going to be square root of 2 over 2, and cosine's negative square root of 2 over 2, so this one's just negative 1. So this one, remember, is going to require probably some simplification. So we're going to end up with negative square root of 3 over 3 minus negative 1 over 1 minus, plus a negative square root of 3 over 3 times negative 1. And we'll end up with a negative square root of 3 over 3 plus 1 over 1 plus square root of 3 over 3. Now, one of the things we can do here is, because I got a denominator 3 in both the top and the bottom, is I can include the fractions with 3. So remember, that distributes to everything. So negative square root of 3 divided by 3 times 3, just going to leave me with negative square root of 3. Square root of, 3 times 1 is just going to be 3. 3 times 1 is 3, and 3 times square root of 3 over 3 is just square root of 3. So at this point, because we don't like that square root of 3, if we were to simplify this, we have to multiply by the conjugate of the denominator, so 3 minus square root of 3 to the top and the bottom. So if we do that and we distribute, negative square root of 3 times 3 is negative 3 square root of 3. Negative square root of 3 times negative square root of 3 is plus 3. 3 times 3 is plus 9. 3 times negative square root of 3 is negative 3 square root of 3. On the bottom, 3 times 3 is 9. 3 times minus square root of 3 is 3 times minus square root of 3. Square root of 3 times 3 is plus 3 square root of 3. And square root of 3 times minus square root of 3 is minus 3. So this simplifies into 12 minus 6 square root of 3 over, these cancel, and you're just left with 6 on the bottom. So 12 divided by 6 is 2. These 6's cancel, so we end up with 2 square root of 3. All right. So I'm going to do both versions of this one because I know this is one we struggled on a little bit. So we have to find the exact value of the expression cosine alpha plus beta, sine alpha plus beta, tangent alpha plus beta. So we're just going to do these ones. Under the following conditions, sine alpha is 15 over 17 and alpha lies in quadrant 1. Sine beta is 4 over 5 and b lies in quadrant 2. So the first part of this problem is just setting this part up. Let me make myself some space here. Okay, we're going to get rid of that little answer there. We'll come back to that. So we have these scenarios. Now, if we look at alpha, alpha is in quadrant 1. Try going down, it does not want to do straight lines. So this is going to be alpha in quadrant 1. We know that sine of alpha is 15 over 17, which is my opposite over my hypotenuse. So opposite is 15, hypotenuse is 17. So what I need to know is, what is x down here? So that means I just need to figure out x squared plus 15 squared equals 17 squared. Or x is just plus or minus the square root of 17 squared minus 15 squared. Let me find that here quickly, since these randomly generate. 17 squared minus 15 squared. So amazingly enough, that's actually going to give us 8. I thought this was a Pythagorean triplet. So remember, because we're in quadrant 1, this is going to be where x is positive. So it could be plus or minus 8, but it's just going to be the plus 8 for us. So now, not only do we know what sine alpha is, we know that cosine alpha is going to be 8 over 17, and we know that tangent of alpha is going to be 15 over 8. So for the next one, for my beta, we might have enough room for R in here. Beta is in quadrant 2. And we know that sine of beta is going to be 4 over 5. So once again, opposite is the 4, hypotenuse is the 5, and we have to find x. So we know x squared plus 4 squared equals 5 squared. So x is going to be equal to the square plus or minus the square root, plus or minus the square root of 3 squared plus 4 squared minus 4 squared because we're subtracting first. So x is either going to be plus or minus 3. And because we're in quadrant 2, x is going to be a negative, so that's going to be negative 3. So now we know that cosine of beta is negative 3 over 5. And we know tangent of beta is going to be negative 4 over 3. Okay. So we want to find, sorry, I gotta move some stuff on my screen you guys cannot see, but it's in my way. We need to find cosine of alpha plus beta, sine of alpha plus beta, and tangent of alpha plus beta. So once again, we know that cosine, just a second, get my stuff working here. Cosine is going to be cosine alpha, cosine beta minus sine alpha sine beta. And then we know, sorry, I'm having allergies while I'm doing this. Sine alpha plus beta is going to be sine alpha cosine beta plus cosine alpha sine beta. And then tangent is going to be tangent alpha plus tangent beta over 1 minus tangent alpha tangent beta. So fortunately, we just found all this out. So cosine alpha, we found right here. That is going to be 8 over 17. Cosine beta, we found right here. It is going to be negative 3 over 5 minus sine alpha, which was given to us. So that was the 15 over 17. And then sine beta, which was also given to us right here. That was the 4 over 5. So you should not have function values left over. All right, so this one is not the most prettiest. So 8 times negative 3 is going to be negative 24. And 17 times 5 is going to be 85. Minus 15 times 4 is going to be 60 over 85. So negative 24 plus 60 is going to be 36 over 85. See if that actually reduces to something. Nope, I think it stays 36 over 85. So that is cosine of alpha plus beta. Now sine alpha plus beta, sine alpha is the 15 over 17. Cosine beta is the negative 3 over 5. Oh, nope, I made a mistake back here. This was a minus and this was a minus. I thought I had a plus there. Let me go back. Let me go back to cosine. I made a mistake. Negative 26 minus 60 is negative 84 over 85. So be careful of those negatives. So back to sine. Sine alpha is 15 over 17. Cosine beta is negative 3 over 5. Cosine of alpha is 8 over 17. Sine of beta is 4 over 5. So we got 15 times negative 3, so that's negative 45 over 17 times 5, which is going to be 85. And then we have 8 times 4, which is 32 over 85. All right. Make sure I don't have, I don't think I left anything. So minus 45 plus 32 is a minus 13 over 85. All right, so tangent alpha plus beta. So our tangents, tangent alpha is 15 over 18. Tangent beta is going to be negative 4 over 3. 1 minus tangent alpha, which is 15 over 8, times tangent beta, which is negative 4 over 3. All right, so to make this work, multiply the top and bottom by 3. So that is going to be, there we go, 45 over 24 minus, and we have to multiply the top and bottom this by 8, minus 32 over 24. On the bottom, we're going to have 1 minus, we see that's going to be 60 plus, actually, because the minus minus, plus 60 over 24. So that 1 can turn it into a 60 over 60. And we're going to end up having 13 over 24. And then we're going to have 120 over 24. Oh, I made a mistake here. I was looking at the wrong number. Sorry, that was a silly mistake of mine. This is a 1, but I got 24 here. I'm going to turn it to 24 over 24. That makes more sense. And then we're going to get 84 over 24. So we're going to be left with 13 over 84. Which you see if you took this cosine alpha plus beta, or this sine alpha plus beta, and put it over cosine alpha plus beta, would have left us with a 13 over 84. All right, and I'll do this one more time. So we want to find, okay, just a second, I thought something was wrong here. We want to find cosine alpha plus beta, sine alpha plus beta, tangent alpha plus beta. But this time, what we are told, so I lost my writing tool there for a second. There we go. We are told that we have tangent of alpha is going to be 1 over 2, and that alpha is between pi and 3 pi over 2. So we have to decide what quadrant that is, and that is quadrant 3. So let me get this one constructed. So quadrant 3, that's where my alpha is. And as we said, we know that tangent of alpha is just 1 over 2. So for this, this is opposite over adjacent. So opposite alpha is 1, adjacent is going to be 2. So we need to find R. Also remember, because we're in quadrant 3, this has to be -1, -2. So R is just going to be the -1 squared plus the -2 squared equals R squared. So that is 1 plus 4 equals R squared, which is going to be 5 equals R squared. So remember R is always positive, so this is just going to be square root of 5. So now we know that sine alpha is just going to be -1 over the square root of 5, or negative square root of 5 over 5. And cosine of alpha is just going to be -2 square root of 5, or -2 square root of 5 over 5. cosine of beta is 3 over 5, and beta is between 3 pi over 2 and 2 pi. So this is quadrant 4. So this is where beta is. And we said beta is going to be, cosine beta is 3 over 5. So that is, sine beta is 3 over 5. So that is the opposite over hypotenuse. Okay. So this is a case where we need to find y. So y is just going to be the square root of 5 squared minus 3 squared, plus or minus. So y is going to end up being plus or minus 4. And because we're in quadrant 4, it's just going to be the minus 4. So we know that sine of beta is going to be minus 4 over 5. And we know that tangent of beta is going to be negative 4 over 3. Okay. So I'm actually going to cheat with the tangents on this one, or not cheat, but show you kind of another way to do it. So you can use 2 different ways. So if we want cosine of alpha plus beta, we saw before that is just going to be cosine alpha cosine beta minus sine alpha sine beta. We know that cosine alpha is going to be right here, negative 2 square root of 5 over 5. Cosine beta is going to be 3 over 5. Sine alpha is the negative square root of 5 over 5. And sine beta is negative 4 over 5. So that is going to be a negative 6 square root of 5 over 25 minus negative, 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 so still minus 4 square root of 5 over 25, which is going to be negative 6 square root of 5 minus 4 square root of 5 over 25. So this one's just not quite as pretty. So these are like, sorry, they're like radicals, so we can combine that into negative 10 square root of 5 over 25, which is going to be negative, because we can divide both these by 5, negative 2 square root of 5 divided by 5. Sine alpha plus beta, that is sine alpha cosine beta plus cosine alpha sine beta. Sine alpha is the negative square root of 5 over 5. Cosine beta is the negative 4 over 5. And then we have plus cosine alpha, which is the negative 2 square root of 5 over 5, times the sine beta, which is the minus 4 over 5. So that is going to be a plus 4 square root of 5 over 25 plus minus plus, nope, positive, because a negative and a negative again, so that's going to be 8 square root of 5 over 25. So that is 12 square root of 5 over 25. So tangent of alpha plus beta, so instead of using the identity, we can actually use the quotient identity, which is, this is just sine alpha plus beta over cosine alpha plus beta, which is then going to be 12 square root of 5 over 25 divided by negative 2 square root of 5 over 5. 12 square root of 5 over 25 times negative, so keep, change, flip. So this is going to be 2 over 25. That's a 25 down here. No, it was a 5, not 2. Let's say I knew something was wrong there. There's a 5. So this is a 5 up here, 2 square root of 5. So the radicals are going to cancel. 12 divided by 2 is just going to be 6. And then we got 25 and 5 here. It's going to cancel, leave me a 5. So this is just negative 6 over 5.